Hello everyone, and welcome to Steaming Up Your Lead Points with District STEAM, a webinar presented to you by GBRI and Con Edison. GBRI is partnered with Consolidated Edison Company of New York for today's presentation. Con Ed is one of the largest investor-owned energy companies in the entire United States and provides a wide range of energy-related products and services to their clients. Con Ed is affiliated with many subsidiaries, which I've listed here on the screen now for your review. The experience of Con Ed and its many affiliates makes them a superior organization to speak on today's energy-related matters, such as the use of steam energy in building projects. District energy systems are a highly efficient way to heat and cool many buildings in a given locale from a central plant. The USGBC created the District Energy Systems Guide within the LEED program in order to grant credit to building projects that are using district energy as a source. The focus of today's course is on steam district energy and how connection to the system can provide points on your LEED building projects. As a LEED professional, you'll be able to assist building projects to become acquainted with the benefits of district steam and acquire points for their building projects. Our instructors will walk us through their lessons learned and make sure we have a thorough understanding of how the system works in relation to LEED. You'll also gain 1.5 CE hours for your participation during today's class. Let's discuss our objectives for today's webinar. By the conclusion of the course, we hope that you'll be able to understand what is District Energy Guide and how it's connected to LEED. You'll learn how to get points for LEED building projects using the DEG. You'll gain knowledge on the benefits of being connected to a district steam system using Con Edison as an example for New York City. And we'll learn and discuss case studies. Now let's get familiar with our instructors today. First, PAULINA MARINKOVIC is a LEED AP with an O&M specialty who serves as an analyst for the STEAM Business Development Department at Con Ed. PAULINA has a degree in environmental management and global climate change from Harvard University. She has extensive experience as a project manager with Samba Energy, where she managed the implementation of renewable energy, energy efficiency, LEED, and sustainability projects in New York City and other surrounding areas. Our second instructor today is ARMAND AGASIAN. He is a certified energy manager, professional engineer, and LEED AP. ARMAND has a degree in mechanical engineering and a master's in environmental engineering from Brooklyn Polytechnic University. He has over 20 years of experience in environmental compliance, HVAC design, construction, and energy management. He currently serves as a project specialist in STEAM Services Business Development Team for Con Ed. All right, let's take a look at our agenda for today's course. Throughout the webinar today, we will be looking at the background of STEAM, background of district energy guidance. We'll take a look then at district energy guidance in relation to new construction, existing buildings operations and maintenance, and version 2.0 of the LEED. We'll examine the opportunities with STEAM district energy guidance, AC incentives, examine case studies, and discuss the evolution and the future facing green technology and LEED. To wrap up, our instructors will walk us through some lessons learned, and at the end, I'll administer a short quiz to earn CE credit for your participation during today's session. So with that being said, I'll go ahead and pass it off to our instructors so we can get started.
Let's start by taking a look at the background on STEAM in New York City. STEAM actually has a long history. The company has been in the business for 132 years. When the company first started in 1882, Steam only had 62 customers. Today, there are roughly 1,700 customers accounts, which represents roughly 3 million New Yorkers. In New York City, district heating system takes the steam produced by steam generating stations and carries it under the streets of Manhattan to heat, cool, or supply power to high-rise buildings and businesses. Some New York businesses and facilities also use this steam for cleaning and disinfection. Approximately 30% of Con Edison's steam systems' installed capacity and 50% of the annual steam generated comes from cogeneration. In the summer months, steam is used for cooling, something that can be accomplished with the installation of absorption chillers. Such trigeneration systems result in additional energy and pollution savings while reducing peak electrical loads. This is Con Edison's service territory. It serves from downtown to 89th Street on the east side and from Battery Park to 96th Street on the west side. We have about 105 miles of main and services. We have 6 steam production facilities, 2 of which produce both electric and steam. We have 105 miles of steam pipes. The system extends from Battery Park to 96th Street. We serve more than 100,000 commercial and residential establishments in Manhattan. Now let's take a look at the background of district energy guidance. The U.S. Green Building Council does not want to penalize a project connected to a district energy system on the LEED program, so they enable you to get credits using the District Energy Guide. The guide was created in 2008 in collaboration among the U.S. Green Building Council, the International District Energy Association, and Con Edison Steam Operations. The guide provides a framework to properly account for the impact of the district energy system within the LEED program. There are 2 guidelines. One is the treatment of district or campus thermal energy used for new construction, and the other one is for existing buildings called treatment of district or campus thermal energy in LEED for existing buildings. These guides are available for free on the USGBC's website. If your project uses thermal energy produced from or delivered to a source outside the LEED project building, the DES document is required. In this particular course, we will be going through the point options provided by the guide created in 2009. If the project you're working on is registered for LEED V4, then you're also eligible to get LEED points using the District Energy Guide. But you need to make sure these points are filed under the appropriate credits, since credits were reallocated or renamed under each category for LEED V4. Something else to note is that under some credits, possible points are different between LEED V3, 2009, and LEED V4. So, for example, the maximum points you can get for credit 1 under LEED V3 is 19, but with LEED V4 is 18. The LEED rating system for new construction and existing buildings is divided into 7 main different categories: regional bonus credits, sustainable sites, water efficiency, energy and atmosphere, materials and resources, indoor environmental quality, and innovation and design process, which is an extra credit category designed to account for unique approaches. One category, energy and atmosphere, is very focused on the issues with which we are involved on a daily basis. On the energy side, the focus is simply the reduction of energy use. On the atmosphere side, the focus is reducing the actual or even potential release of compounds that promote global warming, ozone depletion, and/or general air pollution. The points associated with the energy and atmosphere category have increased from 1/4 of the total to almost 1/3, as shown in this pie. Energy and atmosphere holds 31% of the scoring points distribution. This shows a growing recognition of the primary importance reducing a building's energy use has on helping the U.S. Green Building Council achieve its goals. Some building designers are telling their clients that connecting their projects into district energy will cost them potential points, often due to a lack of understanding of how to properly account for district energy within the LEED rating system. This needn't be the case, as district energy systems offer many potential benefits that can help U.S. Green Building Council reach its goals, such as reducing total energy use through better equipment sequencing through load aggregation, larger equipment with higher efficiency, and increased cycle efficiency through CHP, and better operation and maintenance. In this chart, we can see the number of projects with LEED certification awarded to STEAM buildings, totaling 127 by the end of 2013. These are buildings all currently served by STEAM. Before we get started with points for new construction under LEED 2009, a quick note on LEED v4, which will take precedence on October 2016. LEED v4 has more emphasis on the USGBC's goal of reducing carbon emissions, and this means increased energy efficiencies across the board. Consequently, LEED v4 has adopted ASHRAE standards. Here, you see the 9 categories under which your building project can earn points. Of course, if your building project is registered under LEED v4 and not LEED v3, you can still get points when connected to STEAM. The points would just fall under different credits. Some credit names have changed or become 2 separate credits, and even categories have. Like, for example, location and transportation became its own category. So just make sure that you're allocating the points under the right credit when you're preparing your application in LEED Online. We will focus on LEED 2009 since the District Energy Guide refers to credits in this version. We will now begin taking a look at how the points can be earned for new construction buildings. Let's take a look at District STEAM and LEED for new construction under version 3, 2009. Con Ed meets all the requirements of the prerequisites under new construction. There are 5 credits available in LEED new construction from which a building can. Let's get points through 4 credits with district energy. Credit 1, optimize energy performance. Credit 3 is enhanced commissioning. Credit 4, for enhanced refrigerant management, and Credit 5, measurement and verification. We will now take a closer look into these credits. First, let's go briefly over the prerequisites. For Prerequisite 1, a commissioning agent must be hired to commission the facility and show that it operates as intended. Only downstream equipment needs to be commissioned, which is all heating and cooling systems, any equipment associated with transporting the thermal energy from the DES into the building. For Prerequisite 2, minimum energy efficiency, it refers to demonstrating that the building will be able to operate at a certain minimum energy efficiency level, which is determined as a percentage of energy savings over ASHRAE 90.1. The building needs no information from the DES to demonstrate compliance on this. Prerequisite 3, fundamental refrigerant management, refers to having no chlorofluorocarbons or CFC containing equipment within either the project building or anywhere in the DES, unless there is a phase-out plan in place. Finally, for LEED version 4, the USGBC added an additional prerequisite on building-level energy metering. This prerequisite is only applicable to downstream equipment. All of Con Ed's new customers have energy meters as part of the design, so the DES will be covered for this prerequisite. On this table, you can see all prerequisites and credits that apply to new construction in green. We've reviewed the prerequisites. Now let's take a look at the credits in more detail. Credit 1 is by far the biggest opportunity for a project building to get more points towards the certification. The goal of this credit is to determine how many points can be awarded by constructing a building that is designed to use less annual energy than if the same building was designed based on the minimum requirements of ASHRAE 90.1. So there are two options for modeling. We recommend choosing option number 2, since option number 1, the building standalone scenario, does not account for energy efficiencies in the upstream equipment of the district energy system. You can also earn more points with option 2. So now let's take a closer look at an aggregate building DES scenario. Aggregate building DES scenario. This option helps determine the overall efficiency of the building and upstream DES. First, a baseline building is modeled as if operated using code-compliant on-site fossil fuels like natural gas as a heating system. Second, a proposed as-designed building is modeled utilizing a virtual DES with the same operational efficiencies as Con Edison's district heating system, calculated using the same input fuel as in the baseline building model. Con Edison uses a combined heat and power system, CHP, in which steam is produced and electricity is generated as a waste or byproduct. Now, the model must determine how much of the waste energy will be used by the proposed as-designed building in the model, and then account for all of the cost of the energy input required to produce that waste energy and the corresponding steam. The proposed as-designed building then gets credit in the model for both the steam delivered to the building and the electric power product. It's like getting 2 for 1. Then you get the percentage of improvement. The higher the cost efficiency, the more points you get. Let's take a quick look at Con Edison's system metrics. The company district energy system provides heating utilities to its customers. This figure shows the basic schematics of the heating system. This energy information is based on data that Con Edison updates yearly. You can see in our breakdown that almost 100% of fuel input is natural gas, and that cogeneration enables an annual 168 kilowatt generation per 2.46 MMBTU of steam, while simultaneously 1 MMBTU of steam is delivered to customers. This shows that our steam distribution efficiency is 87%. To more clearly understand the picture of efficiency, we can take a look at an example. According to estimates from the EPA, the conventional generation heat and power system uses 147 units of energy, 91 for electricity and 56 for heat to produce 30 units of electricity and 45 units of steam. On the other hand, we have Con Edison's district steam system using CHP, cogeneration, which in this scenario would use 125 units of energy input to produce the same 75 units of useful energy fuel, heat and electricity, from one single source. This results in a total system efficiency of 64%, compared to 51% for the conventional energy. Now, it is important to note that the Con Edison system efficiency of 64% takes into account the efficiency of the entire district steam energy network in the New York metro area where we serve, and includes distribution and condensate losses. Now let's quickly take a look at the back-end calculation side of this. As we've learned, the overall energy efficiency of Con Edison's steam district energy system is 64%. This translates into, per every 2.46 million BTU of fuel consumed at the station, 1 million BTU is delivered to the building, together with 168 kilowatt-hour of electricity that is produced simultaneously, as we reviewed previously. The LEED guideline considers this as energy credit in the calculation model. Let's take a look at an example. Assuming, since prices fluctuate, that natural gas is $13 per million BTU, based on average general rates reported by our gas department and steam department at Con Edison, and that electricity is 18 cents per kilowatt hour, and assuming we're comparing Con Edison's CHP system to a typical site boiler with an 85% efficiency, we can proceed with the following calculation. The steam cost for 1 million BTU delivered equals the gas cost multiplied by the plant heat input, which is $13, times 2.46 million BTUs divided by the 1 million BTU delivered, which equals $31.98. The value of the simultaneously produced electricity equals the power-to-heat ratio multiplied by the electric cost, which is, as we learned, 168 kilowatt delivered by the 1 million BTU delivered times 18 cents, which equals $30.24. Now, the net cost per million BTU of steam purchased equals the $31.98 minus the $30.24, which amounts to $1.74. It's pretty good. Let's now look at the case of an on-site boiler in which the cost per million BTU produced equals the building load divided by the boiler efficiency times the gas cost, which is 1 million BTU divided by the 85% efficiency times $13, which adds up to $15.29. This is about 90% cost improvement. And even if the boiler were 95% efficient, then the on-site boiler cost per million BTU produced would be $13.68. So steam would still be the better option. This is a sample of the point breakdown available for projects going through the LEED new construction rating system. This is not an all-inclusive list, but we're showing this to give you an idea that 18 to 19 points out of 100 are available in the category. We believe that a project has an opportunity to gain most of these points by simply connecting to a district steam system that utilizes CHP. Now let's look at Credit 3, Enhanced Commissioning. 2 points are awarded if commissioning is performed to a higher level by meeting the following requirements. The building must hire a third-party commissioning agent with more than 2 years of experience. The agent will review the building design prior to bidding. The agent will review submittals, the operations and maintenance manuals, and develop a systems manual. The agent must also verify that proper training occurs. The district energy system itself must also meet the guidelines if the project building is greater than 50,000 square feet or if the DES supplies more than 20% of the building's total energy, or if the building is pursuing points through Credit 1, or if the building's connected load is more than 50% of the DES total load. One of this will most probably happen, so the DES will need to comply as well. In this case, and the case of Con Edison, the company complies with all of these. The USGBC awards 2 points to projects that show a combined weighted ozone depletion potential and global warming potential less than a defined threshold. This does not apply to the DES itself since Con Edison does not sell chilled water to customers. However, customers using steam to generate chilled water through absorption chillers can take advantage of steam for this credit since the refrigerant in this case would be water. The U.S. Green Building Council awards 3 points to projects that develop and implement a measurement and verification plan. The requirements are all downstream equipment needs to be accounted for, like tertiary pumps, heat exchangers, condensate pumps, etc. Material needs to be provided to show the district energy system's efficiency claimed in Credit 1 by including a measurement and verification plan that shows this information, and the energy delivered by the DES to the building must be metered. Con Ed complies with all of these requirements. Now we will move into how to get points for existing buildings. District steam and existing buildings. Con Edison meets all the requirements of the prerequisites under existing buildings. There are 5 credits through which a building project can get points with district energy. Credit 1 is for optimized energy efficiency performance. Credit 2 for existing building commissioning. Credit 3, performance measurement. Credit 5 for enhanced refrigerant management. Credit 6, emissions reduction reporting. And now we will take a closer look into these credits. First, let's take a quick look at the prerequisites for existing buildings briefly. For the first one, energy efficiency and best management practices, the building owner needs to document the system sequence of operations, develop a building operating plan, a systems narrative, and document the preventive maintenance schedule and conduct an energy audit. For prerequisite number 2, minimum energy performance, requires that the total energy of the building be metered. Consequently, the building must achieve a minimum energy performance rating under Energy Star of 69 using EPA's Portfolio Manager. The actual energy performance of the DES is not considered in the score. As for prerequisite number 3, fundamental refrigerant management, the requirements are identical to those of LEED new construction, prerequisite number 3, with one exception. If the building owner does not have any financial interest in the DES, then the requirement does not apply, which means the DES would not need to meet the chlorofluorocarbon requirement. In this table, we can see all the prerequisites and the credits that apply to existing buildings highlighted in green. Let's take a closer look at the credits. Optimize energy performance. Here, you can earn up to 19 points in LEED 2009 or up to 18 points in LEED version 4. Credit 1 requires that the total energy of the building be metered. The metered energy performance must achieve an energy rating of at least 71 points in the Energy Star Performance Rating System using EPA's Portfolio Manager. The only information needed from the district energy system is data on the district system's overall efficiency and the fuel mix used to generate the utilities used by the project building. We will work with our customers on a case-by-case scenario to provide all material needed to satisfy these requirements. The district energy system itself does not need to be commissioned in order for the project to meet the requirements of the credit. Only the building project needs to. With credit number 3, you can earn up to 2 points under LEED 2009. The building must have a building automation system, or BAS, to monitor and control major building systems. However, this monitoring does not apply to the DES components that are not within the project's building itself. Now let's take a look at Credit 5 for Enhanced Refrigerant Management. The U.S. Green Building Council awards 2 points to projects that show a combined weighted ozone depletion potential and global warming potential less than a defined threshold. This does not apply to the district energy system itself, since Con Edison does not sell chilled water to customers. However, customers using steam to generate chilled water through absorption chillers can take advantage of steam for this credit, since the refrigerant in this case would be water. Now moving to Credit 6, Emissions Reduction Reporting. The idea of this credit is to document the greenhouse gas emission reduction benefits of building energy efficiency measures. The project must either track and record emission reduction delivered by energy efficiency and other building measures, or use a third party for voluntary reporting or certification program. The greenhouse gas emissions from the district energy system must be included. If you are connected to a district steam service, you can take advantage of their carbon emissions reduction. Every year, Con Edison publishes their carbon footprint. This is public information. If you need additional data, you can always contact Con Edison and someone will assist you. District Energy Guidance 2.0, a look at what's new. First, we have thermal energy storage. New guidelines include specific TES provisions aimed at accounting for the positive benefits of thermal energy storage in district plant applications. Combined heat and power, CHP guidelines specific to district energy have been added to the latest guidance document version. These CHP-related guidelines include default efficiency numbers, similar to previously included chilled water, steam, and distribution defaults, allowing designers to model CHP when data is not available. Energy rates. The new guideline includes formulas designed to convert the fully burdened rate into an actual rate. Also, realistic energy rates can be used in models without district energy owners having to reveal all of their financial data. Another addition is about absorption chillers. The new guidelines include provisions for modeling absorption chillers in district energy applications in both the baseline and proposed building. Default efficiencies for absorption cooling are also included for use when actual data is not available. Commissioning. The requirements have been modified slightly to align better with LEED for existing building requirements. Step 1 points. The first guideline required a Step 2 energy simulation model be completed before a building could earn any points beyond those required under the minimum energy prerequisite. The new guideline allows up to 4 points under Step 1. This means a project can achieve up to 4 points under the Energy Efficiency Credit, Energy and Atmosphere Credit 1, without having to include the impact of the district energy system. Now let's move to opportunities and benefits with STEAM District Energy Guidance. There are many benefits a building can get from being connected to district STEAM. A building can increase valuable space There is no need to allocate space for large boilers and equipment since steam is delivered directly to the building, providing more space for amenities like a pool, a gym, a terrace, or a business office. It also helps save money. Steam cooling costs less than electricity on the hottest days of the year, so it's more cost efficient. You also avoid the costs of buying, operating, and maintaining boilers and equipment. These costs can be allocated to other building subprojects. By being connected to district steam, you can also practice sustainable development and improve the environment. You can improve your ENERGY STAR rating, earn points toward LEED certification, reduce air pollution, and shrink your carbon footprint. Another benefit of steam is its purity. This is good particularly for restaurants and hospitals. Con Edison steam is produced in boilers that utilize purified New York City water and boiler treatment chemicals that are in accordance with the FDA specs from Section 173.310 Boiler Water Additives. You can find the detailed information in the FDA's data site using the link in the slide. Basically, the FDA specification lists 6 additives that cannot be used if steam will come in contact with milk. Con Edison does not use and has never used any of those additives in boilers providing steam to the New York City steam distribution system. Con Edison monitors steam purity by continuously monitoring the steam conductivity in each steam main leaving each power plant. Con Ed reports each incident if there is ever an exceedance on the limits to the New York State Public Service Commission, along with corrective actions that were taken immediately. In addition to the limits prescribed by the PSC, Con Edison has instituted a limit of 0.10 ppm sulfate. Now let's take a look at the business case for LEED. What are the triggers driving more buildings to get certified? One important reason is that client and market demand for LEED is growing. There is a 35% client demand for LEED and a 33% market demand. Also, the new Class A office space is green. Lease-up rates for green buildings can typically be 20% above average. Owners of green buildings reported that their ROI improved by 19.2% on average for existing building green projects and 9.9% on average for new projects. Operating costs decreased by 13.6% for new construction and 8.5% for existing building projects. Annual utilities cost per employee in green facilities was 675.26 cents lower than in non-green facilities. And building value increased by 10.9% for new construction and 6.8% for existing building projects. Now let's take a look at an example in terms of financing. Fannie Mae provides green financing solutions tackling the triple bottom line by supporting increased cash flows, better quality housing, and reduced energy and water usage. They call it the green financing business, which creates incentives including 10 basis points off any loan for properties with a green building certification, 10 basis points off on Empire loans in New York City, 10 basis points off Green Preservation Plus loans, and up to 10% more in loan proceeds for Empire loans and 5% more for Green Preservation Plus loans. Now let's take a look at the benefits the Green Financing Program by Fannie Mae gives. It enables increased cash flow with reduced energy expenses, lower water costs, and new revenue from electricity-generating solar systems. Safeguards long-term value with a green building certified multifamily property. It provides access to a broader mortgage-backed securities investor market interested in Fannie Mae's environmentally focused green mortgage-backed securities. And it also offers fast executions and closings thanks to their unique delegated model with Fannie Mae lenders. Here we can see a comparison of Fannie Mae's green financing products. You can see that for buildings with a green building certification, there is up to an 80% loan-to-value ratio and other perks. A lot of financial terms here, but the bottom line is that with certified greener buildings, there are better financing options. Now let's take a look regarding condensate reuse. As steam cools, it changes state from vapor to liquid. This liquid water is called condensate. Automatic valves called traps remove the condensate and help ensure safety and prevent erosion of pipes and other equipment. But if your building wants to be more energy efficient, this condensate can be reused. One way is to use it to preheat domestic hot water. Condensate can be used to preheat domestic hot water through a heat exchanger. This will not only offset steam consumption, but will also reduce the amount of water used to temper the condensate before it is discharged into the sewer. As shown in this sketch, this method requires a water-to-water heat exchanger, piping, and possibly pumps. Another reuse of condensate is for cooling tower makeup. The use of condensate as cooling tower makeup decreases the amount of city water that is used to temper the condensate and for cooling tower makeup. The total amount of water drained into the sewer is also reduced. As indicated in the sketch, this method will require piping, pumps, and a diverting valve. Both of these methods result in reduced consumption of city water. In both cases, condensate should be tempered with city water prior to use. Hence, the plumbing systems would have to be modified accordingly.
Next, I will cover financial incentives available for steam air conditioning, customer case studies, new technologies enabling distributed generation using steam. Steam Air Conditioning Incentive Program. Originally rolled out on October 2012, the Steam AC Incentive Program has been expanded and now includes all electric networks located within the Con Edison steam footprint. There are two types of incentives. One is a lump sum incentive for equipment purchase, and there is a maintenance incentive to support cost of maintenance. In addition, all incentive levels have increased. We have added incentives for single-stage absorption chillers, and we now have a custom project option. Custom project option allows customers to propose projects that are not covered in the prescriptive options, such as upgrades to their existing steam chillers. These incentives are reviewed by Con Edison and are determined on a case-by-case basis. Please note, to receive any of these incentives, chillers must be operational by June 1st, 2016. These are the current incentives for the Steam AC program. For new chiller installations, incentives are determined on a dollar per ton basis, determined by the chiller type and tonnage. Incentive levels range from $325 per ton for a single-stage steam absorption chiller to $600 per ton for steam turbine chillers. The incentives will cover up to 65% of the delivered equipment cost. Once again, the custom chiller project option is determined on a case-by-case basis. In addition, customers that offset more than 500 kW of electric load are eligible for a large project bonus. Projects that offset more than 500 kW up to 1 megawatt can receive an additional 10%, and projects over 1 megawatt can receive an additional 15%. This bonus is applied on top of the 65% cap. How to apply. By simply going to coned.com/steamac, you can fill out the program application and be sure to include supporting material, such as incentive worksheets, equipment selection, and if required, letters of authorization from the customer, engineering assessments, and a load study. send the completed application to steamac@coned.com. And if you have further questions, please call us at 212-460-2011. Today we will cover some case studies of new and existing customers to show you the value proposition STEAM service provides. 157 West 57th Street, one of the tallest residential properties in Manhattan. Designed by 1994 Pritzker Prize-winning architect, the striking modern glass tower has transformed the famed skyline of New York City. It provides residents with breathtaking views of Central Park to the north, downtown to the south, and both Hudson and East Rivers. The building has 92 luxury condominiums above the 210-key Park Hyatt New York Hotel. STEAM service fit into the design to maximize floor space, achieve the unique curved building roof, and allow for such amenities as on-site laundry service, spa, and restaurant space. .450 Lexington Avenue, owned and operated by RXR Realty. RXR Realty, a premier owner, operator, and developer with an extensive portfolio across the New York tri-state area. The building has 35 stories, 950,000 square feet. Steam is used for heating and hot water. The customer's focus in choosing STEAM is energy conservation and sustainability, Energy Star score, space saving, and operating simplicity. 450 Lexington Avenue has a first-rate mechanical and steam meter room. As you can see, it is truly immaculate. Steam traps are maintained and inspected monthly. 69 traps in total are maintained and inspected every month and fully assessed once a year by a specialist contractor. This ensures that their system is safe, reliable, and energy efficient. Pipes are insulated without any noticeable leaks in any of the joints or connections. The building reuses their steam condensate to preheat their hot water system. A building management system provides full control to efficiently monitor and operate its systems. As a result, 450 Lexington uses 20% less steam on average compared to similar steam customers. 51 Astor Place, developed by Edward J. Minskoff Equities. It's a 13-story, 400,000 square foot building, and it takes up the entire block between 3rd and 4th Avenues in New York City. 51 Astor Place houses business, retail, and educational tenants. Located next to New York University and Cooper Union, like 157 West 57th Street, 51 Astor Place is also designed by a Pritzker Prize-winning architect. Although the floor plates go from 42,000 square feet in the base to 25,000 square feet in the tower, the building wastes no space by offering 2 green roofs on the 5th and 13th floors. A building management system monitors and controls all building systems to optimize operating efficiencies and energy consumption. The customer's focus in choosing STEAM was to eliminate on-site and local emissions, utilize rental space, and earn points towards LEED Gold certification. .1285 6th Avenue is a STEAM customer since 2003. It is an office building of about 1.7 million square feet with 42 floors. It is currently managed by Jones Lang LaSalle. The building wanted to upgrade their chiller plant to lower their operating costs. One option was to install steam turbine control panels on 2 of the 4 1,275-ton chillers to increase their efficiency. The second option was to go through an elaborate and expensive process of installing a new 1,000-ton electric chiller. The engineering assessment was performed by a consulting engineer to compare both options. The initial economic analysis favored adding an electric chiller. However, after the steam AC incentive was taken into account, the customer decided to retain steam cooling capability. 1285 6th Avenue was accepted under the custom project option in the steam AC program. 1285 upgraded their steam panels, making their steam turbines more efficient during part load operations. With the installation of 2 steam operating panels, the building will be able to reduce its operating costs. The steam AC incentive will pay for 50% of the project cost, an additional 10% because the project avoids more than 500 kW of additional electric capacity. With the incentive and energy savings combined, the building can recover a portion of the capital costs of the project with a 2-year payback, as well as a portion of maintenance costs over the next 10 years. 77 Park Avenue, also known as the Griffin. 77 Park Avenue is an elegant pre-war white glove service condominium using boilers with number 6 oil to provide heat and hot water to its 116 units. The building has 15 stories and over 158,000 square feet. The building is currently upgrading to Con Edison steam service, eliminating the on-site oil fire boilers, and will be using steam for heat and hot water. 77 Park had several options before choosing steam. Switch temporarily from heavy number 6 oil to number 4 oil. Move to lighter number 2 oil with the prospect of having to introduce biofuels in the future. Convert to gas burners or set up a dual fuel system. And finally connect to the steam system. The condo board recognized the value of steam in terms of health, space, market value, and rates, which is why they chose to connect to the steam system. One of the main drivers to making the move to steam was the elimination of on-site emissions. Eliminating the need for a boiler exhaust stack, residents enjoy cleaner air on their rooftop. The stack space running through the core of the building will be used as a venting duct for the renovated laundry room. Connecting to steam opened up space to add value to the property, with the future addition of 2 amenity bathrooms and a gym with enhanced access for those with mobility issues. Also, selecting Con Edison steam, the property benefits from stable, reduced rates. In the next section, I will speak briefly about 3 companies that provide technologies that allow a customer to generate electricity while simultaneously reducing the pressure of incoming steam. When steam enters a customer's building, it is typically between 140 to 180 psi. Our customers typically use pressure-reducing valves, or PRVs, to lower the pressure of steam in order to be distributed throughout the facility. As steam is passing through the PRV and the pressure is being reduced, some energy is also being wasted. As you can see here, these systems will be installed in parallel to your pressure-reducing valves. When these systems are running, the PRVs are bypassed and electric power is produced, and low-pressure steam needs are provided to the building. Overall, these systems are meant to provide customers with electric savings without impacting the operation of their steam system in any way. ENERGENT Corporation is a California-based company that has 2 products on the market that utilize steam turbine generators. The micro steam turbine, as seen on the right, is a steam turbine generator set that consists of a Euler turbine connected to a planetary gear, which in turn is connected to an induction generator. The Euler turbine is the main component of the set and is a radial outflow turbine designed to handle the saturated steam of similar quality to the steam that is supplied to a customer's building. The system accepts steam loads between the range of 4,000 to 20,000 pounds per hour. The maximum power of 275 kW can be produced with a steam load of at least 13,500 pounds per hour. This system is ideal for our larger customers that have higher steam loads during the summer period in order to benefit the most from the electric energy produced. We currently have 5 customers that have installed the micro steam turbine and have been able to benefit from the electric savings. The nano steam turbine is similar to the micro steam turbine in that it also utilizes the Euler turbine technology. However, this design utilizes a high-speed generator, and power electronics are in place of a traditional gearbox. The nano steam turbine was also designed to meet a larger customer market, since it is able to accept smaller steam loads ranging from 1,000 to 4,000 pounds per hour. The maximum electric output of 100 kW is produced with a customer steam load of 4,000 pounds per hour. The image on the right shows the nano steam turbine currently installed in a power plant. The system itself is significantly smaller than the micro steam turbine, taking up less room in a facility. Elliott Group is another manufacturer that designs and manufactures steam turbine generator sets that allow customers to capture energy that is wasted through an existing PRV. Elliott Group allows customers to custom design a steam turbine generator set that best fits their steam load profile. They have a steam turbine product line that is specifically designed to produce power for customers looking to replace a PRV. These custom designs come in a variety of sizes that will produce a range of electricity depending on how large your steam load is. Elliott Group will work with each customer to find the right steam turbine generator set to best fit their needs. HELIEX Power and CONTINUUM Energy. The two previous manufacturers that I have spoken about have utilized steam turbine generators to produce electricity from incoming steam. Another technology that can be used for steam pressure reduction and electric production is a screw expander, which can be seen here on the right. A partnership between HELIEX Power and CONTINUUM Energy has allowed a clear focus on sustainable energy and has brought this product, which utilizes a screw expander, to the American market. The screw expander set is made up of a single screw expander, an induction generator, and a generator interconnection module. There are two models available, as you can see here, the HP145 and the HP204. The HP145 is a better fit for customers that have smaller steam loads, especially during the summer, while the HP204 will be a better fit for our larger customers. Each model is available to generate a range of electric output dependent on the steam input. The last technology I want to speak with you today about is from a company known as ELECTRATHERM. ELECTRATHERM designs and manufactures systems known as the Green Machine, which generate fuel-free, emission-free electricity from low-grade waste heat into power. ELECTRATHERM also utilizes a twin screw expander as the power block for the system. Unlike the other four technologies that I have just spoken about that work in parallel to a pressure reduction valve, this system works by utilizing condensate. Most of our customers currently are cooling the condensate and then releasing it to the sewer. This system utilizes hot water to produce power between 35 kW and 110 kW, depending on the hot water flow rate. Customers will be able to benefit from savings from the electric production as well as from water savings. So in conclusion, some lessons learned. We learned that buildings connected to steam district energy can gain LEED points using the District Energy Guide. We learned how to get points for LEED building projects using the District Energy Guide. We learned what prerequisites and credits are involved. We learned that Con Edison's steam district system meets all the requirements for your building project to apply for points for LEED. We learned that there are several benefits from being connected to a district steam system. And we learned that new technologies in the market may enhance efficiency levels for future steam use in the building. To finalize, you can find a copy of the guide on USGBC's website. The guidance document will provide to you the necessary information to take advantage of the points you can get through district steam. And we will, of course, work closely with you to provide all necessary information to fulfill all prerequisites and credit requirements. For further information, please contact us.
Before we wrap up today, I did want to share with you information about a free Con Edison class that is offered through their offices. It'll qualify for 8 professional development hours, and it will cover similar topics to this conversation today about district STEAM. However, it'll be much more in-depth, and it will offer an opportunity for a live question and answer session with instructors similar to ours today. If you'd like more information, I have put contact details on the screen now. You can reach out to them via phone or email for registration information. All right, that will conclude our presentation today. We do appreciate you watching, and we hope that you found this information